Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at graphing any parabola. Specifically, we're looking at graphing a quadratic equation that isn't in turning point form. So we're going to graph y equals x squared plus 4x plus 3. So what we want to do is we want to write it in the form y equals a x plus h squared plus k. These are really easy to graph, remember, because the turning point is just negative hk. So we're going to convert this equation into this form, and remember we do that by completing the square. So let's complete the square on this so it looks like this. So I'm going to write it as y equals x plus 2 squared. Why did I choose 2 of all numbers? Because 2 is half of 4. So the number that goes inside here is half the coefficient of x. So what goes outside the brackets? Well, we need to take our 3 and subtract 2 squared. So 3 minus 2 squared, 3 minus 4 is negative 1. Why do we need to do that? So remember, x squared plus 4x plus 3, not a perfect square. X plus 2 squared gives us x squared plus 4x plus 4. We needed to add a 4 here because that makes this here a perfect square. What I've circled is x plus 2 squared. But you can't just add a 4 and not change it. You need to subtract it. So that's why we subtract. That's why we end up with 3 minus 4 and negative 1 there. So instead of graphing y equals x squared plus 4x plus 3, we're just going to graph y equals x plus 2 all squared minus 1, because these two are the same graph. So this one's easier to work with. We can read off the turning point straight away. So the turning point will be negative 2, negative 1. So we're going to go ahead and plot this turning point. We go across to x is negative 2, down to y is negative 1. So the turning point will be here. But 1 point is not enough to determine a parabola. The parabola could go like this or it could go like this. We don't know. So in addition to the turning point, we're going to find the y-intercept, and we're going to do that by letting x equal 0. So x equals 0 gives the y-intercept, y equals 0 gives the x-intercept. So x equals 0, we substitute into either equation, doesn't matter, this one or this one. So if x equals 0, y is just going to be 3. The y-intercept is just 3. Whatever this value of c is, when it's not in turning point form, that'll be the y-intercept. Of course, we could have just gone y equals 0 plus 2. 2 squared is 4, minus 1 is 3. It doesn't matter whether you substitute x equals 0 in here or here, you should get y equals 3, and that, of course, means that the y-intercept is up here at 3. So what about the x-intercept? Because you'll often be asked to show the x-intercepts. Well, this time we're going to let y equal 0 to find the x-intercepts. So then we have 0 is equal to x plus 2 squared minus 1. So what we can do now is factorize this using difference of 2 squares. So when we use difference of 2 squares, we're going to square root the first. So the square root of x plus 2 squared is just x plus 2, and I put that in both brackets. Then we square root the other one. We're going to square root 1 and put it in both brackets. 1 gets a plus between them, 1 gets a minus. Of course, x plus 2 plus 1 is just x plus 3. And then x plus 2 minus 1 is x plus 1. Now we use the null factor law. When you have something times something equals 0, either the first something equals 0 or the second something equals 0. Negative 3 is the value of x that makes this bracket equal 0. Negative 1 is the value of x that makes this one equal 0. So the x-intercepts here are at negative 3 and negative 1. So I'm going to plot them here and here. I now have more than enough information to draw the graph of y equals x squared plus 4x plus 3. So after we've plotted the turning point and the intercepts, we just join it up knowing the shape of all parabolas. So that is our final graph. All right, let's look at another example. So to graph this parabola here, I need to first put it in turning point form, and I do that by completing the square. Now when you're completing the square, if x squared has something in front of it, you must first take out that as a common factor. So note that negative x squared is the same as negative 1x squared. So what we're going to do is first take out a common factor of negative 1. So what do you times by negative 1 to get negative x squared? What do you times by negative 1 to get negative 2x? And what do you times by negative 1 to get positive 3? So now I'm just going to complete the square on this. I'm going to leave the negative 1 alone. So when I'm completing the square, this will become x plus 1 squared. Why did I choose 1 to go in the bracket of all possible numbers? Because 1 is half of 2. And then outside the brackets will be negative 3 minus 1 squared. So of course negative 3 minus 1 squared is just negative 3 subtract 1, which is 4. So I'm just going to expand this bracket now. Negative 1 times x plus 1 squared, I just leave it like this, and then negative 1 times negative 4. So here it is in completing the square form. So I know that the turning point is going to be negative 1, 4. The turning point has x coordinate that's the opposite of this, negative 1, and this is the y coordinate of the turning point. So I'm going to go ahead now and plot the turning point at negative 1, 4, which is up here. That's the turning point. So now I'm going to find the y-intercept. So to find the y-intercept, you let x equal 0. So if x equals 0, y is just going to be 3. That's the same answer we'd get if we put it here. X equals 0, you get negative 1 plus 4, which is positive 3. So x equals 0, y equals 3. That means that the y-intercept occurs there at 3. So now let's find the x-intercepts. So what we're going to have to do is factorize this using the difference of two squares. So because it's got to be a perfect square minus a perfect square, we're just going to write it like this. So to factorize using the difference of two squares. So we get two brackets. We square root the first. We square root the second. I want to put it in brackets. And then one bracket is going to get a plus, one bracket is going to get a minus between it. So clearing this up, this first bracket will be 2 minus x and then minus 1. So 2 minus 1 is 1 minus x. And then in this bracket, we will get 2 plus 1 is 3 plus x. So the two intercepts, how are we going to get them? Well, if we change y to 0, then we just use the null factor law. Either the first thing equals 0 or the second thing equals 0. If 1 minus x equals 0, then x just equals 1, because 1 minus 1 equals 0. If 3 plus x equals 0, x equals negative 3. They're the two solutions. 1 makes the first bracket equal 0, negative 3 makes the second bracket equal 0. So this parabola is going to have an x-intercept here at minus 3 and here at 1. Now we just join them up and we have the parabola. So we make sure we put arrows on each end and we write the equation and then we're done. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.